All right, so this warm up was meant to just do a little bit of probability review before we start our next unit. So we'll just go over these together. So, number one, when rolling a standard dice, what is the probability you roll an odd number? So, remember, anytime you're rolling a dice or anytime you're doing probability, it's the outcome you want over the total outcomes. So, when I'm rolling a dice, there are 6 total outcomes. And then the probability you roll an odd number. Well, of the 6 numbers, right? I have 1, 2, 3 of them are odd. So 3 out of 6, which I can reduce to 1/2 as my probability. All right, so then if I look a jar containing 12 caramels, 7 mints, and 16 dark chocolates, what is the probability of selecting a mint, not replacing it, and then selecting a dark chocolate? So first, my total number of candy here, if I do 12 plus 7 plus 16, I have 35 pieces of candy. So the probability of getting a mint would be 7 out of 35. And then I'm not replacing it. So it means I took one out, and I'm assuming I took out a mint. So now there are only 34 pieces left in the bag. And I want to select a dark chocolate. So in this case, there would still be 16 dark chocolates left. Because we always assume in the first one we got what we wanted. So we got a mint here. So there's still 16 pieces of dark chocolate left. So I'm going to reduce this before I multiply. Because 7 over 35 are both divisible by 7, so I could reduce this to 1/5. And then if I divide these by 2, I get 8 over 17. That just makes my multiplying easier, and it's less to reduce later. So if I go ahead and multiply now, I would get 8 over, and then 17 times 5 would give me 85. And I don't think I can reduce that anymore. So my answer would be 8 over 85. Okay. On a deck of 52 playing cards, what's the probability you draw a spade, replace it, and then you draw another spade? So there's 52 cards in the deck. Spade is a suit. So remember, there's 4 suits. So 1/4 of the cards are spades, which means 13 out of 52 are spades. And then I'm going to replace it, which means in the second time, I'm putting the card back. So there are going to still be 52 cards left. And there are still going to be 13 spades because I put the deck back exactly how I found it when I replace it. So 13 out of 52 reduces to 1/4. So this is really 1/4 times 1/4, which would give me 1 over 16. All right, you have a jar of marbles. 7 are red, 12 are blue, and 6 are yellow, and 9 are white. What is the probability of drawing 3 marbles in a row that are not blue without replacing? So if I add up 7 plus 12 plus 6 plus 9, I would have 34. So I have 34 to choose from. And then I want it to not be blue. So the only ones there's 12 of them that are blue, which means there are 22 of them that are not. Right? If I add up 7, 6, and 9, I'd get 22. And then I'm not replacing it. So I drew the first one and it wasn't blue out of my 22 out of 34. So that means in the next round, right, there's only 33. And I already took one out that's not blue. So there's only 21 that are not blue left. So then I take another one out. That's 32. And again, I got another one that's not blue, so there are only 20 left. All right, so if I try to do some reducing before, both of these I could divide by 11. So I would get 2 here and 3 here. And then I could divide these both by 4. So I get 5 and 8. I'm not sure I can divide 34 by anything. That would be helpful. Maybe 2. All right, I could divide 34 divided by 2, and I get 17. So if I divide this by 2 and then get 17 here, and then, so I have 20, I have a 1, a 21, and a 5 on top. So 21 times 5 would give me 105. And then 17 times 3 times 8 would give me 408 at the bottom. I'm not sure there's anything left to divide out from there. All right. So the next one, you have a fair coin. What is the probability of flipping the coin 4 times and it lands on tails every time? So every time you flip a coin, your chances of getting tails are 1/2, and they don't change, right? Each flip is independent. So if I flip it 4 times, I'm just trying to see the probability that I get tails. So 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 would give me 16. So I end up with 1 out of 16 chance of getting 4 tails in a row. And then the last one, in a deck of 52 playing cards, what's the probability of drawing a faced card, replacing it, and then drawing a diamond or a heart? So you have 52 cards. Drawing a faced card, so there's 3 face cards. They each have 4 colors or 4 suits. So there's 4 kings, 4 queens, and 4 jacks. So there's 12 total face cards. So then you replace it, so you still have 52 left in your deck. And then you're drawing a heart or a diamond. So there are 13 hearts and 13 diamonds. So that means you have 26 options here. So if I reduce, I can divide both of these by 4, which would give me 3 out of 13. And then I can divide both of these actually by 26, and this would give me 1/2, right? Diamonds, hearts and diamonds are your red cards. They're half the deck is red, half the deck is black. So you have a 50-50 chance of getting a red card. So now when I multiply this together, I get 3/26. All right, so that's just a simple review into probability as we start this chapter with probability distribution.